Hello all. Today we'll be discussing three popular data serialization formats: ProtocolBuffers, Avro, and Parquet. These formats are widely used in the world of big data and are designed to make it easier to store and process large amounts of data. Let's start with ProtocolBuffers. ProtocolBuffers are a language-agnostic binary serialization format developed by Google. The idea behind ProtocolBuffers is to define a schema in a specific format, which can then be used to generate code in various programming languages. This code can then be used to serialize and deserialize data in the format specified by the schema. One of the benefits of ProtocolBuffers is their smaller size. Since they are binary, the serialization after the ProtocolBuffers is applied to your data, the output is binary. These take less space than other formats that are text-based serialization, such as XML or JSON. This makes ProtocolBuffers a good choice for storing and transmitting large amounts of data efficiently, or in general to be the communication layer in between applications. Another benefit of ProtocolBuffers is their speed. Since they are binary, since the output is binary and have a predefined schema, the output can be quickly serialized and deserialized. This makes ProtocolBuffers a good choice for application that needs to process data quickly, such as real-time data streaming or just services when one service calls another. Now let's move on to Avro. Avro is another data serialization format that is used for storing and processing big data. Unlike ProtocolBuffers, Avro is a text-based format, which means that it's easier to read and modify by humans. Avro also has a schema that describes the structure of the data being stored, similar to ProtocolBuffers. One of the benefits of Avro is that it's self-describing. This means that the schema is stored along with the data. So it's easier to work with the data without having to reference an external schema file. Another benefit of Avro is the support for complex data types. Avro supports nested structures as well as the ability to define custom data types. This makes it a good choice for applications that need to store and process complex data. Finally, let's discuss Parquet. Parquet is a columnar storage format that is used for storing large amounts of data. Unlike ProtocolBuffers and Avro, Parquet is not a serialization format. Instead, it's a file format. So it's like .jpg, .png, that is optimized for storing large amounts of data efficiently. One of the benefits of Parquet is its efficient use of storage space. Since it's a columnar storage format, it can store similar data types together, which makes it more efficient than row-based storage formats when we do aggregation on a specific column, for example. This can lead to significant space savings and also for optimization of if we do a sum on a column, we want the rows of the column to be together, especially for large data sets. Another benefit of Parquet is its support for compression. Parquet files can be compressed using various algorithms, which can further reduce the storage requirements. This makes Parquet a good choice for applications that need to store and process large amounts of data cost efficiently. So, which format should we choose? The answer depends on our use case. If we need a language-agnostic format that is fast and efficient, ProtocolBuffers may be a good choice. If we need a format that is easy to work with and support complex data types, Avro may be a good choice. If we need a file format that is optimized for storage, high storage efficiently, Parquet may be a good choice. If we want something for analytics, Parquet may be a good choice. If we want something for applications to communicate one with another, ProtocolBuffers may be a good choice. It's important to keep in mind that these formats are not mutually exclusive. In fact, it's common to use multiple formats in big data pipelines. For example, we may use ProtocolBuffers to serialize data at the source, then use Avro to store the data in a more readable format, then finally use Parquet to store the data compressed in a columnar format for efficient processing. So this was a brief comparison in between ProtocolBuffers, Avro, and Parquet.